Welcome to the ACU Bootcamp series on the JPS Interop channel. In this episode, we'll be discussing how to adjust the receive audio level of radio resource interfaces of the ACU interoperability gateways and modules. This will ensure that the receive audio derived from an attached donor radio is at the proper audio level before it's shared with other disparate radios in the interoperable environment. The ACU DSP and ACU radio resource interfaces of the ACU interoperability gateways and modules contain an audio gain control that will assure that the receive and transmit audio levels are at the proper levels, such that when shared, the audio level will not over or undermodulate disparate radio systems. Since interoperable voice communications passes through both receive and transmit audio gain controls within the ACU gateway, any misadjustment of one will affect the other. It sometimes becomes difficult to determine which to adjust during setup and troubleshooting activities. We'll use a systematic approach to set both receive and transmit audio levels separately, which will prevent us from making improper and improvised adjustments during actual operations. An important tool that we'll be using during setup and troubleshooting activities is the ACU handset and the backplane. All ACU gateways are equipped with a push-to-talk handset that allows the operator to listen and converse with any of the radio and telephony systems associated with the ACU gateway. The handset has full duplex PTT priority, which gives an operator the ability to break into any conversation at any time. An important attribute of the ACU handset is that it interacts with the backplane of the ACU gateway. Whether the backplane is digital or analog, this is where the sharing of radio or telephony communications with our allied agencies takes place. The gain or audio level of the ACU handset with respect to the backplane is fixed and cannot be adjusted, and since this level cannot be changed, the handset and backplane can be used as a standard. The optimal audio level or signal strength is 0 dBm. Throughout the ACU Bootcamp series, we'll be referring to signal strength or audio power in terms of dBm instead of using watts or milliwatts. And if you're interested, dBm is 10 times the logarithm in base 10 of the power in milliwatts. dBm is a convenient way for engineers and technicians to express power levels when setting up equipment or troubleshooting, and it'll be easier for us as well. For example, if we were to measure the receive audio output of a receiving donor radio with a power meter and the meter read 0 dBm, the equivalent power in watts is 1 milliwatt. If we increase the receive audio output by 1 dB, where 1 dB or 1 decibel is the relative increase or decrease of power in dBm, the resulting absolute output power will be 1 dBm or 1.259 milliwatts. That was a 1 decibel or 1 dB step. If we increase the power by 1 more dB to plus 2 dBm, the resulting absolute output power will be 2 dBm or 1.585 milliwatts. Maybe you can see a pattern. The power values represented in watts become long and unwieldy, whereas the power expressed in dBm are much simpler. And if we reduce the power level or signal strength, the values in watts become even more difficult to comprehend. Note that the dB values can be negative and positive. However, the negative dBm values still represent real and absolute quantities of signal strength and audio power, just like the positive values of dBm. So as we move forward, we will no longer talk about audio levels in terms of watts or milliwatts, but refer to audio levels in terms of absolute dBm values. It'll make our job easier. Lastly, when we talk about changing or adjusting power levels expressed in dBm, we will use the term dB or decibel. The change from plus 1 dBm to plus 2 dBm is a 1 dB or a positive 1 decibel step. Audio level changes from a negative 40 dBm to a negative 50 dBm. That would be a negative 10 dB change, which is much easier than saying the equivalent change from 100 picowatts to 10 picowatts is a negative 90 picowatts. So let's leave the units of watts behind and we'll apply what we just learned. If we understand that the ACU is optimized to operate at 0 dBm, it makes sense to make certain that the donor radio delivers 0 dBm to the ACU through the DSP module or radio resource interface. But because of the different performance attributes of land mobile radios, we can assume that the receive audio derived from the different donor radios will probably not be at 0 dBm. Launch the controller application. In this example, we'll be using the ACU controller. The Waze controller and the browser-based controllers have similar configuration panels. First and foremost, when aligning or troubleshooting any interface module, create an interoperable cross-connection with the ACU handset. No other assets should be in the interoperable net. The ACU handset will allow you to listen to the donor radio's receive audio, which will help in determining other audible anomalies. Open the module settings panel, in this case the ACU controller, double-click the module icon. This is a good opportunity to enter the description of the radio or the name of the allied agency that's associated to the donor radio. For instance, you can also enter a telephone number, just in case you need to call someone to replace a battery in a portable donor radio. You can also change or customize the on-screen module icon. You can also load the appropriate radio template or immediately begin the alignment. I sometimes prefer not to use templates as it helps me better understand the alignment, and it also forces me to address each of the settings to achieve better performing interfaces. It's up to you. It's okay to load radio templates and profiles to get started. As you become more familiar with the different settings of each interface, you'll notice the TX and RX designations used to represent transmit and receive respectively. The TX and RX designations refers to the active state of the donor radio. These terms will be helpful especially during troubleshooting activities. For instance, if we determine the quality of audio being transmitted from the field is poor, we need to determine the active state of the donor radio at that very moment. Is the donor radio receiving or is it transmitting? In this case, the donor radio is receiving. That means we can improve the audio quality by adjusting the RX or receive parameters of the DSP interface. Conversely, if someone in the field complains about the quality of the transmission that they're receiving from the ACU Gateway, we need to determine the active state of the donor radio at that very moment. Again, is the donor radio receiving or is it transmitting? In this case, the donor radio is transmitting to the field, which means we can correct the audio quality by adjusting the TX or transmit parameters of the DSP. By observing the active state of the donor radio, this will simplify troubleshooting of the ACU radio interfaces. So let's continue. With the DSP module in an interoperable group with the ACU handset, use another radio in the field to transmit a test count to the donor radio. Observe the signal LED associated with the DSP module or the ACU resource interface. Non-modular gateways such as the ACU 5000 or the ACU-M have similar signal LEDs on their faceplates. The signal LED will turn on and turn off at a threshold of 0 dBm. Again, 0 dBm is the ACU's optimal operating point. If the signal LED does not light during the test count, the receive audio coming from the donor radio is too low. And if the signal LED is on constantly during the test count, the receive audio coming from the donor radio is too strong. Since we're dealing with the receive audio level of the donor radio, we need to adjust the RX audio level in the module settings panel. The values that we see in the receive audio levels adjustment are absolute values in dBm ranging from plus 12 dBm to minus 26 dBm. If we were to use a power meter, those values are the receive audio signal strength coming from the donor radio. If we measure plus 12 dBm, we then need to select plus 12 in the RX audio level adjustment. This is an example of a donor radio receive audio output that is very loud. By selecting plus 12 from the menu, the ACU interface is effectively attenuating the receive audio by 12 dB, resulting in 0 dBm at the backplane, which again is ideal. If we measure a low receive audio level coming from the donor radio, let's say minus 26, we can assume that is very low receive audio. From the RX audio level adjustment, we can then select minus 26. In this case, the DSP module is boosting the receive audio by 26 dB, resulting in 0 dBm at the backplane, which again is ideal. But instead of using a power meter, the easiest way to adjust receive audio level is to simply observe the signal LED while the donor radio is receiving the test count from the field. Testing 1 2 3 4 5. Testing 1 2 3 4 5. Testing 1 2 3 4 5. Select the receive audio level, click apply, repeat until the signal LED flashes during the presence of each syllable during the test count. Testing 1 2 3 4 5. Testing 1 2 3 4 5. Testing 1 2 3 4 5. If the dBm units are confusing, you can use the unitless number within the brackets as a volume control. If you want to make the signal LED turn on more often, select a larger value within the brackets. If the LED is on continuously, you need to lower the gain. Select the lower numerical value within the brackets. Continue making small adjustments until the signal LED flashes with each audible syllable. Don't forget to click apply each time to commit the change. And do not be fooled by the audio being emitted by the ACU handset or the integral speaker. The audio might sound fine, but might actually be too weak or too strong once delivered to the ACU backplane. This will create an under or over modulated condition with the disparate radio and telephony systems associated with the ACU Gateway. Always rely on the signal LED and not the ACU speaker to assess the receive audio levels. Repeat the adjustment of the receive audio level for each of the radio interfaces, and when performed in conjunction with the transmit audio level adjustments, which we'll discuss in the next episode, you will have achieved unity gain or a gain of 1, meaning what enters the ACU Gateway will be the same virtual level leaving the ACU Gateway. This ensures disparate radio and telephony assets are not over or under modulated. So this concludes another ACU Bootcamp episode. In the next episode, we'll discuss the adjustment of the transmit audio levels. This will be the audio delivered to the donor radio from the ACU and subsequently heard by the allied agencies in the field. Every couple of weeks, we should have a new episode of useful technical information that will help you better understand ACU technology and provide your organization and agency dependable, interoperable communications. And if you have any suggestions on future episodes you would like us to include, or if you're interested in more information on our products and solutions, please give us a call or visit us at jpsinterop.com.